Assalamualaikum and hello everyone. My name is Ahmad Ilham bin Masura Aladdin and my metric number is 229143. Today I will present about the assignment 1, set up the x86 that are given by Dr. Khairul Mizam. So for the first step, we need to create new project. Create new project, and we open the file that are given, average 4. So the question asks us to print the result. So the assembly language does not have any built-in print functions. Normally, printing requires many instructions and system call. So we need to include io.in. We will see at the hub. So print hexadecimal. Data is printed in hexadecimal representation. The print hexadecimal must need percentage include io.in to make it execute properly. So we need to include that at the first line of the average 4. So we need to type print underscore hex to result. So this command will execute properly when the include io.in are present in the average 4. So this to print the result. So then we need to build. Click build and build this. So it is built successfully. So then we need to debug first, and then we need to show the registers and the memory. So it is already be shown the memory and also the registers. So after that, as you see at the average 4 file, there is data and result as the two variables. So you need to put the variable into the memory. So the first is result, data. So we need to, the type is hexadecimal, word, and the array size is 4. The next variable is result, also hexadecimal, word, and the array size is 1. So at the average 4, there is EBP and ESP, that is for correct debugging process. So the debugging process start at line 7. So we need to do step over. This sub EAX begins by initializing AX using the instruction EAX. This clears the entire EAX registers, and because AX is the lowest 16 bits of EAX, this ensures AX starts from 0 before we start adding numbers. So when we do step over, the EAX will become 0. So the EAX has become 0. So the next step is we set the loop counter using move ECX4. We have 4 values in the data section, so ECX is set to 0. Is set to 4. This register will control how many times the loop repeats. So this is, we set the counter to 4, ECX. So we do step over. So the ECX has become 4. So the next line is we set the starting index with move ESI. It displaces ESI just past the last data element because each value is a 16-bit word or 2 bytes. Starting at offset 8 allows us to step backward through the array. So when we step over this line, the ESI will become 8. So that is completed. So after that, inside the loop, we move ESI to the previous word using 2 decimal ESI instruction. Each decimal subtract 1. So doing it twice subtract 2, which moves ESI to the previous 16-bit value. So when we do these 2 line, the ESI will become back to previous 16-bit value. we have seen that the ESI has become 6. So for this line, next we add the current data value to AX using add AX data plus ESI. This instruction reads the word at the address data plus ESI and adds it to AX. This is how the program accumulates the sum of all 4 numbers. Then we have the loop AW instruction. Loop automatically decreases ECX by 1, and if ECX is not 0 yet, it jumps back to the label AW and continues to loop. So the loop will continue until the ECX becomes 0. So we need to do loops 4 times. Step over, and we see that the ECX has decreases by 1. We will do it until the ECX becomes 0. So the loop has completed by seeing the ECX turn to 0. After the loop finish, we clear the DX using sub EDX EDX. This is needed because 16-bit division uses the combined DX AX register pair, and DX must be 0 to avoid incorrect result. So the EDX will become 0. So you see it. So the next step, we load the divisor using move CX4 because we want to divide the total sum by 4. So you see this line. So we need to do step over again. Then the program performs the division using division CX. This divides the value in AX by the value in CX, giving us the average and stores the result back into AX. Then we do step over. After calculating the average, we store the result using move result AX. This put the final value into the memory location called result. Finally, we print the result using print hex2 result. This macro converts the number into hexadecimal and prints it on the screen. So we see that the output shown is 2800. So we continue until the debugging process becomes finished. So the debugging process is finished. Then that's all from me. Thank you.